not there yet, though. She's only 11. In your notes, if you turn to page 8. Borrow your mom's coats? No. No, but
I just wear my own. I know. I did wash shirts on. I just wear those.
yeah, her shirts,
Yeah.
shoes.
Oh no, she tries to wear my shoes and it makes me mad because she has fat feet and they stretch my shoes out. It's a recurring argument.
I'll be sure to email your mom. By the way.
It's a recurring argument.
So in your packet on page 8, we're going to start with some factoring fun problems, but we're going to factor with trig instead of factoring with algebra. The first group of your problems for homework tonight is also fun factoring problems with trig and not algebra. That like back group of even problems, I have them up on the board, but I sent them through Remind as well. So feel free to take a picture before you leave, or if you have Remind, they were sent through Remind. But some even problems, I like the even ones better than the odds in those 60s, so I got them up here. So the directions will say to factor, and that's all the directions say. So pretty much if you can factor it, it's probably simplified. But we have secant squared theta minus 1. And you might have noticed in your homework, there was a fishy for number 39, a phi was used for 35. Different variables will be used for the angles, different Greek letters. So in this one, we just have regular old theta. And it says to factor. And if you can train your brain to still think back to algebra, factoring trig is no different than factoring an algebra problem. So just to kind of show you how it works, instead of saying secant squared, I'm going to just kind of put a little line down here, maybe. There we go. And pretend secant is an x. You can just say, hey, let's let secant be x, just to make sure you're kind of thinking about how it factors. So if it said x squared minus 1, how would you factor it, Chelsea?
X minus 1 times x plus 1.
Yeah. X minus 1, x plus 1. That's called the sum and difference of squares. So it's also called a conjugate because the middle terms cancel, which is how you get that x squared minus 1. Well, in trig, factoring is no different than algebra. It's just you have the word secant instead of x. So this still factors, but it factors as secant theta minus 1 instead of x minus 1, and secant theta plus 1. Same property. It's just you have a trig name instead of an x. But it doesn't change the way you factor it. Factoring is still factoring. So that first one is factor. Our goal of factoring in the end, when we get to the end of the chapter, will be to start solving. So now that it's factored, we can solve those pieces, just like with x. The reason we factor is to solve for x. So we'll be factoring to solve for the parentheses. But that's not till the end of next week. So looking at number 2, or letter B, we have secant squared, or cosecant squared, minus cotangent minus 3. What's wrong with this problem? Besides that it has trig in it. Virginia. Yeah, these guys don't match. And when you're factoring, we usually have ax squared plus bx plus c. Well, the terms have to match in order for us to be able to factor them. So that means we can't factor first. You're going to have to refer to your identities page. What identity can we use, Virginia? Yeah, so that is one of the 3 Pythagorean identities. 1 plus cotangent squared equals cosecant squared. So when the problem is cosecant squared, we can take that out and replace it with whatever it's equal to, which is 1 plus cotangent squared. After you replace it, if there's any like terms you can combine, you want to do that. Well, here we have a 1 and a negative 3, so combine those together. So it becomes a minus 2. So if you prefer to think algebraically, do the same thing that I did over there. So instead of having cotangent squared, you can pretend that that says x squared minus x minus 2. It just says cotangent instead of saying x, but you're factoring it the same way. And that's using that AC, multiplying the first number, which is really a 1, because there's a coefficient of 1 here, times the negative 2. It's that same process. So we have a negative 2, Michael, the two numbers that multiply to be negative 2, but combine to be a negative 1. Negative 2 and positive 1. So if it were x, I'd say x minus 2 and x plus 1. But it's cotangent, so we would say cotangent minus 2, cotangent plus 1. But it's still the same algebraic process. You're still taking a times c. Because the coefficient in front of the cotangent squared is a 1, we don't have to go through the whole long grouping process. This is the basic AC method factoring. So factor it, plug in those factors in parentheses with the cotangent. And then again, this is it. Like there's nothing else you can do, it's factored. We use the identity first, we factored it. Questions? So number 5 is a little more challenging than number 6. So we're going to skip to number 6 first, and we'll finish with number 5. The reason number 5 is so challenging is because you don't know what it's supposed to equal. It just says make sure it's not in a fraction. Number 6 is a little nicer because it says to verify the identity, which means we now know what it's supposed to equal. It's kind of like a proof, but not really an algebra or a geometric proof because we're going to use algebra and trig. So looking at the left side of the problem, yes, it looks a little crazy because we have two fractions here with trig things in them, and an addition sign. Our goal is to take all of this and break it down until you get cosecant. Once you have cosecant, you're done. You've solved the problem. You've verified it. So thinking about fractions and algebra, what do you usually do if you have fractions? Like our goal is a plus sign. It's not a times in the middle there. It's a plus. What do you usually do if you're adding fractions? Chelsea?
You have to find the least common denominator.
Yeah, we have to find the least common denominator. Again, this is a plus. If it was times, we could cancel out those signs, but it's a plus. So adding fractions means you have to have a common denominator. If you look at the two denominators, each one of these are called factors. The common denominator is a multiple of those two denominators placed together. So Chelsea, the one on the left, we need to multiply by sign. Whatever you do to the bottom, you've got to do the same thing to the top. So Chelsea, sign times sign is sine squared. So that's my new fraction on the top of the left. On the right, there's a sign. So what does it need? Michael, what does it need? It needs 1 plus cosine. Again, we need to do that to the top as well. So Michael, what would the numerator on the right side become?
1 plus cosine squared.
Yeah, close. Cosine times 1 is?
Oh, cosine.
Cosine. And then he said plus cosine squared theta. So you're distributing cosine to 1, distributing cosine to cosine. So you're multiplying by that whole quantity. So that's the top, my new numerator. There's a plus sign still in the bottom or in the middle. But now this is one fraction because we multiplied by the common denominator. But I'm going to keep the denominator factored because when we solved problems in chapter P with fractions, the denominator is kept factored because factored is simplified. So instead of distributing the sign through the denominator, we're just going to keep the sign out. So it's like the numerator has a separate rule than the denominator. The numerator we do multiply because our goal is to combine or add the numerators. The denominator we actually keep factored because it's a common denominator and we don't really try and combine that stuff together. So it stays as a factored form. So we did the algebra first. We did the addition sign. We combined the things together. Usually after you do algebra, you try and use an identity. So looking at the top, is there an identity that we can apply to the top of this fraction? If you're not sure, look at that, look at the sheet, seeing if there's something that looks like anything on that sheet. Virginia?
Sine squared plus cosine squared could be 1.
Yeah, does it matter that they're not directly next to each other? No, addition is commutative. So you can add a 1 and you can add a 3 even though they're not next to each other like we did up in the factoring problem. We added 1 and negative 3. They weren't next to each other, but we could still combine them together. So as long as they're on the top of the fraction, sine squared plus cosine squared is the identity, that Pythagorean identity that we'll use the most often, and those together make 1. We still have that cosine sitting by itself because we didn't do anything with it. We just hopped over it. We skipped it. And then on the bottom, we still have the sine on the outside being multiplied by 1 plus cosine. So Jenna, what do you notice? Yeah, so the quantity that's on the top is exactly the same as the quantity on the bottom. And because you're multiplying by that entire quantity, and it's exactly the same, they cancel. Jenna, what is 1 over the sine? The cosecant. What were we trying to get it equal to? The cosecant. So once you get it equal to the cosecant, then you verified the problem. So we took the original problem, we found common denominators. We really used 2 identities. The Pythagorean one was the big one that we used, because that enabled us to combine things together. And then the other one was that reciprocal identity, 1 over the sine is equal to the cosecant. Questions? I like that problem. I mean, besides the common denominators, fairly straightforward. Alright, so let's go to the one that I skipped because I said it was a little harder. It's a couple extra steps. So the directions say rewrite the following so that it's not in fractional form. So if we can get it out of fractional form, we should pretty much be simplified. There could be a couple of different answers for this one depending on how you approach it, but our goal is to get it out of fraction form. And all we have on the top is a 1. On the bottom is 1 plus sine. So I need you to think back algebraically when you have fractions. There's something with the denominator that we do to multiple types of fractions involving denominators. So it's an algebraic process that we use to work with denominators. Chelsea, what do you think?
You multiply by 1
And what do you mean when you say that?
You would multiply by 1 minus 9.
Yeah. So that's a process that we use when you have square roots. It's called rationalizing the denominator. When there are i's, we multiply by the conjugate. So if I have 1 minus I, we multiply by 1 plus I. There was a question like that on the midterm, a couple of questions that I think we went over one in the review as well. So we're going to use the conjugate fact here to see if that helps us. Because otherwise, like, there's not an identity that we can use because this isn't a sine squared, it's just 1 plus sine. So like sometimes there's nothing that you can do besides trying to manipulate the fraction, and a conjugate is an algebraic process that we can use. So just change the way the fraction's written. Didn't remember whatever you do at the top, you gotta do at the bottom. And it's still gonna be in a fraction form, so it's not gonna like help us immediately, but hopefully it kind of gets us one step closer. So the top is just 1 times what was there, so that stays as 1 minus sine x. Chelsea, if you FOIL the bottom together, what does that give you?
1 minus sine squared.
Yeah, so we have 1 times 1, and then the inner terms cancel because a negative sign and a positive sign, and then it's minus sine squared x. So we did an algebra step. After you do algebra, the goal would be hopefully that there's an identity that's involved in the problem. So look at your identities. Is there something we can use, Sabrina?
Is it the Pythagorean identity with sin x squared plus cosine squared plus 1?
Yeah. So the whole goal of using the conjugate was to get something that is squared so that we can replace it with an identity. So if you have 1 minus sine squared, Sabrina, how would this identity, what would be replaced in for 1 minus sine squared? Yeah, it just becomes cosine. So right here is cosine. If you take the sine to the other side, cosine is equal to 1 minus sine squared. So cosine squared is equal to 1 minus sine squared. So it's still a fraction, but it's taking the 2 pieces that were in the bottom and at least making them one term. So we still have 1 minus sine, but now it's only over cosine squared, instead of it being over a 1 plus a sine. So my 2 pieces in the denominator now are at least down to 1 piece. Questions so far? Okay, so then the next part is a little weird because you're so used to combining fractions together, but instead we're going to do the opposite. So the previous problem that we just did, we found a common denominator, we combined 2 fractions together. We're going to now split this apart and look at it as 2 separate fractions, because hopefully we can then try and use some reciprocal identities. So when you split a fraction apart, you take the numerator and you place it over the common denominator. So my 1 in the numerator is over the common denominator of cosine squared. There's a minus sign, and then you do the same thing with the second term in the numerator. It's the sine. You're also placing it over the common denominator. So that's called separating a fraction, decomposing a fraction, which is actually a whole chapter in chapter 7 that will decompose fractions, break them apart. So we now have these 2 separate fractions. They have a common denominator. If I were combining them together, I'd get this, but we broke them apart. The one on the left, we have 1 over cosine squared. What can we change that into? Virginia? Yeah, that just becomes secant squared. That's your reciprocal identity. It's okay that it's squared. It's still the reciprocal identity. So one part now is not in fraction form anymore, which means we're getting close. The second piece, I'm going to kind of continue to split apart. So if there's a cosine squared down there, what does it mean if something's squared? We have an x squared, a y squared, a z squared, a cosine squared. Chelsea?
It's multiplied by itself.
Yeah, it's multiplied by itself. So I'm going to use that fact and just try and split it apart. So in this problem, our goal is just to like split the problem apart. So cosine squared really means that there are 2 of them. Don't forget the minus sign. If it was x squared, really it means we have x times x. Well, cosine squared means you have cosine times cosine. So again, they mean the same thing, it's just a different way of looking at it. Is there an identity that we can try and use to continue to simplify this, Virginia? So this part here becomes tangent. But this piece still is still in the denominator. So we still have, if that kind of separated, we still have a 1 with the cosine. And we have secant squared. And then one more time, Virginia. And then this part here now changes to secant, which you probably could have done both in that step if you wanted to think about this having a 1 on the top. So that problem is totally different than any of the ones that you've done, because algebraically you're so used to combining things together, and in that problem instead we like separated it. So we continue to separate and break down the fraction. Would you have been able to get that on your own? Probably not yet, but you'll do a problem similar to this one in the homework. So use the notes to try and see like how did we pull the fraction apart. So it's sometimes when it says to get it out of fraction form, we gotta just separate the fraction and try and break down that denominator. Questions? That one's hard. So I'm going to look at 2 problems from your homework. So if you just want to find your homework, I might get to one of the 2 problems, but I knew there were a couple of questions. So in 29, we had secant to the 4th minus tangent to the 4th. And if you think of this as x to the 4th minus y to the 4th. So when in doubt, think algebraically. What could you do with something that says x to the 4th minus y to the 4th? Or secant to the 4th minus tangent to the 4th. two squares. So how would that break down,
So
Michael?
it would be x squared minus y squared, and then x squared plus y squared.
So that's that sum and difference of two squares, whatever you want to call that. So Michael, how would you break down secant to the fourth minus tangent to the fourth?
It would be secant squared of x minus tangent squared of x, and then secant squared of x plus tangent squared of x.
Nice job. So now it's factored. Is there an identity that applies to one of those two parentheses? So look at your identity sheet. Is there an identity that has something like this in it? Anna? The first one. Yeah, because it's 1 plus the tangent squared equals the secant squared. So this guy here is just equal to 1. That's why the answer, I think, was letter F, which is secant squared plus tangent squared. Questions? So tonight's homework, 43 to 57 odd, the 60, 62, 66, 70, the answers are on the board, and then 81. 49 and 66. Any takers? Kate, you'll try 49. How about 66? Good old Mary Lemieux. You do Mary Lemieux problem? Yeah. All right, what do we have, Keith? These are worksheets.